When we make a map, we're trying to convey some information about a part of the real world. But every part of the world contains far more detail than we could ever convey easily on a map, not least because maps always show the world at a smaller scale than it really is. The infinite detail of the real world means that it can sometimes be challenging to manage all the data we want to include on a map. In fact, to make any map, we have to simplify the real world. One way to do that is to think of the world as being made up of different types of features. A feature could be something from the physical world, such as the outline of a building, the course of a street, or the location of a tree. A feature could also be an event that happened in a particular place, such as the location of a particular crime. There are infinite types of features that we could put on maps, but computers typically store individual features in three different ways: as points, as lines, or as polygons. Points are used to represent physical features such as streetlights, as well as the locations of individual events. Lines are used to represent physical features such as walls and roads, as well as behavioural features such as routes from one place to another. And polygons are used to represent features like the outline of a building or the area covered by a police force. Most files that store spatial information can only store points or lines or polygons, not a mixture of different types. That means it's usual for information about different types of feature to be stored in different files. For example, if we wanted to find the nearest police station to a set of crime locations, we would probably have a dataset of police station locations and a separate dataset of crime locations. Once we have all the data we need, we can build a map by adding each type of feature as a separate map layer. Every map is made up of multiple layers of data stacked on top of one another. For example, we might have a layer representing roads, another layer representing buildings, and so on. It can be easy to end up trying to show a lot of data on a map, either because the map shows a large area or because it shows a lot of detail. Eventually, the amount of data becomes hard to work with. If that happens, we can simplify the data by converting the points, lines, or polygons on a map into what's called a raster layer. A raster layer is made up of a grid of cells, sometimes called pixels, with each cell having a single value associated with it. In this course, we'll see several examples of raster layers on maps. The first are called base maps, which show a lot of different physical features in an environment as a single layer. Base maps like this can be very useful because they mean we don't have to deal with separate layers for every type of feature that we want to show on a map. But because we can't then access each feature individually, we can't easily choose what information is shown on a base map or how features are represented. That means it's important to choose a base map that shows the information we need in a clear way. Fortunately, there are lots of useful base maps available online. So to summarise, spatial data can be represented as points or lines or polygons. We build maps by stacking layers of features on top of each other. And we can represent features as rasters to make them easier to work with.